Our first example is to solve the inequality 3 times the quantity x plus 4 is greater than 5x minus 8. We are to graph the solution set and write it in interval and set builder notation. We begin by simplifying each side, and then we apply the properties of inequality until we get the variable on a side by itself. Distributing on the left, we get 3x plus 12 is greater than 5x minus 8. Subtract 5x from each side. This gives us negative 2x plus 12 is greater than negative 8. Now we subtract 12 from each side to get negative 2x is greater than negative 20. To solve for x, we must divide each side by negative 2. This gives us x is less than 10. Remember to reverse the inequality symbol because we divided by a negative number. This means that any number less than 10 is the solution to this inequality. To graph the solution set, we draw a number line and mark 10 on it. Then we shade the portion that corresponds to numbers less than 10, which is to the left of 10. Because 10 is not a solution, we place a parenthesis on 10. The set builder is a set of x such that x is less than 10. For the interval notation, read the graph from left to right. There is no left bound to the solution set. We designate that as negative infinity. The right bound to our solution set is 10. So we write open parenthesis, negative infinity, comma, 10, close parenthesis. Example B is to solve the inequality 16 is less than or equal to 8 times the quantity x minus 2 minus 3x plus 5. We first simplify each side of the inequality. This gives us 16 is less than or equal to 8x minus 16 minus 3x plus 5. Combine like terms on the right to get 16 is less than or equal to 5x minus 11. Add 11 to each side to get 27 is less than or equal to 5x. Divide each side by 5 to get 27 fifths is less than or equal to x. This is equivalent to x is greater than or equal to 27 fifths. To graph, we shade everything to the right of 27 fifths. And place a bracket on 27 fifths since it is included in the solution set. The set builder notation is the set of x such that x is greater than or equal to 27 fifths. The interval notation is written as open bracket 27 fifths, comma, infinity, close parenthesis. Remember that we never use a bracket with plus or minus infinity, as we can never reach such a number. Example C is to solve the inequality 1/4 x plus 2/3 times the quantity x plus 3 is greater than or equal to x minus 1/2. We multiply each side by the least common denominator to produce an equivalent statement without fractions. The LCD is 12. So 12 times 1/4 x is 3x. 12 times 2/3 times x plus 3 is 8 times x plus 3 is greater than or equal to 12 times x is 12x minus 12 times 1/2 is minus 6. So we have 3x plus 8x plus 24 is greater than or equal to 12x minus 6. Combining like terms gives us 11x plus 24 is greater than or equal to 12x minus 6. Subtract 12x from each side. We get negative x plus 24 is greater than or equal to negative 6. Subtract 24 from each side, and we get negative x is greater than or equal to negative 30. To solve for x, we have to divide each side by negative 1. Remember, this will reverse the inequality symbol, so we get x is less than or equal to 30. On a graph, we represent this as shading to the left of 30 and a bracket on 30. So the interval notation is open parenthesis, negative infinity, comma, 30, close bracket. The set builder notation is written as a set of x such that x is less than or equal to 30. Example D is to solve the inequality 3 times the quantity x minus 3 plus 17 is less than or equal to 2 times the quantity x plus 4 plus x. Simplifying each side, we get 3x minus 9 plus 17 is less than or equal to 2x plus 8 plus x. We combine like terms to get 3x plus 8 is less than or equal to 3x plus 8. This is an example of an identity. It is true for all values of x because the left side and the right side are always equal. The solution set is a set of all real numbers. But we can also subtract 3x from each side to get 8 is less than or equal to 8, which is always a true statement. The graph then is the entire number line shaded. The interval notation is written as open parenthesis, negative infinity, comma, infinity, close parenthesis. The set builder notation is a set of x such that x is a real number.